Good morning, students. Welcome to science lesson. My name is Teacher Tony. I'm going to guide you to study about physics chapter this semester. Today, we are going to talk about Unit 9, Forces and Motions. Please, students, open your book, page 128. Subchapter 9.1. The title is Seeing Forces. Look at this picture, students. This picture tells us about logging truck in New Zealand. The truck engines must pull with a big force to make its heavy load of the log move along the road. It means that if we want to make object move, of course, we have to give the object force. What is force, students? There is some definition of the force. For the simple one, we can use this word to explain about the force. They are pushing and pulling, stretching or turning. These are some of the things of the force can do, students. These are the example of doing force. 1. You use a force to push the broken down car. 2. You use a force to pull a drawer open. 3. You use a force to stretch a rubber band. 4. You use a force to turn a door handle. Based on those examples, students, we know that there is 4 words to describe about force. They are push, pull, stretch, and turn. One more time. Push, pull, stretch, and turn. These are some of the ways in which a force can act, students. Look at this picture. There is 3 kinds of picture. Those picture actually people do force. The first one, there is a boy play baseball. If you want to make a ball move, of course you hit this one, right? This one is the same thing, you push the ball. Or the girl, if you want to release the arrow, students, of course you have to stretch the rope of this thing. Okay, and then after that, if you release the arrow, arrow will move. Another one, there is boy ride the bicycle. If you want to make the bicycle move, of course you have to push the pedals like this. Do you understand, students? Okay, let's move to another concept. Forces cannot be seen, students, but our body allows us to feel the force. Why we can feel the force? Remember, students, you already learned about this one in biology chapter. We have a nerve ending in our skin which can detect pressure. For example, press gently with your finger on the tip of your nose. You will feel the force of your finger push on your nose, right? Or sit on the chair. You can feel the upward push on the chair. Or put your hand on the chair and sit on it. Your hand is squashed by 2 forces. One, the force of your body pushing downward, and then the second one, the force of the chair pushing upward. Students, we cannot see this force, but we cannot feel their effect. In the drawing, the force is represented by arrow. A force arrow is a good way to represent a force because it shows the direction in which the force is acting. Look at this one, students. When there is somebody sit down in the chair, there is force going upward, represented by the green arrow, this one. How to label force arrow, students? A force arrow shows us the direction of the force, right? We label the arrow to show two things, students. One, the object that the force is acting on, and then the second one, the object that producing the force. For example, how to label the force arrow, students? A force arrow shows us the direction of the force. The label the arrow to show two things that are the object that the force is acting on and the object that is producing the force. Look at this picture, students. The woman is pushing the shopping trolley. The force arrow is labeled to show which object is doing pushing and which object is being pushed. This helps us to understand where force comes from. For example, this picture. The one who doing push is the woman, and then the one is being pushed is the trolley. Force appear when two objects interact each other. For example, this one, students. Between the woman and then the trolley, they are interact each other. Another example. There are magnet and nail. Magnet can attract an iron nail. The magnet and the nail interact. The magnet is pulling and then the nail is being pulled. This one is the same thing with the first one. The one who doing force is magnet, and then the one who get force is the nail, students. Do you understand, students? Okay, let's move to another one, students. From this explanation, students, we can make summary. 1. Forces act in the object to push, pull, stretch, and turn. We can say that force is push, pull process. Forces happen when two objects interact with each other. A force arrow shows the direction of a force. Subchapter 9.2 Forces big and small. Forces can make things move. It's like I said before. You have to push the shopping trolley to start it moving around the shop. You have to pull on handle to open the drawer. Look at the picture. This one is the example of forces. If you want to make the car move, of course you have to giving force, represented by the green arrow. If you want to bell ring, of course you have to push the button of the bell. If you want to bring the book, of course you have to give it the force in the books like this. How to measuring force? In science, if we want to know if one force is bigger than another, we don't simply guess, students. We are not allowed to do that. We make measurement. How can we measure the force? We use an instrument called a force meter to measure a force, or Newton meter. That one is the same thing. You can say force meter or Newton meter. In this one is the picture, one of type of force meter or Newton meter. How to use this one? How to use this equipment or instrument? Look at this one, students. The first, check that the force meter reads 0 before you start it. Look at the scale. Before you use this one, of course you have to make sure the scale in 0 Newton like this, in 0 reading. And then after that, attach the hook of the force meter to the block like this. And then hold the ring at the other end of the force meter and then pull the block. And then read the value of the force from the scale. For example, in the picture, this one is 3 Newton. How a force works, students? There is a spring inside of force meter. Inside of this force, there is spring, students. The pulling force stretches the spring, and this moves the indicator along the scale. The bigger scale means bigger force, or the bigger force, the further the indicator moves. For example, students, look at this picture. If you want to measure the force of the chair like this, of course you do like this one, students. Attach the hook of the force meter in the chair like this, and then directly you have to read the scale in the force meter. For example, like this one 60 newtons means that the force of the gravitational due in the chair is 60 newtons. What is the unit of the force? We measure force in newtons. I mentioned it before, students, when I say 60 newtons, 3 newtons. So the unit of the force is newtons. This unit is named after Isaac Newton on English Science, who explained how force affect the way things move. To make easy, we can write big N instead of Newton. You don't need to write down Newton. You can replace the name as big N like this, capital N. How much is a Newton? If you hold an apple on the palm of your hand, it presses down with the force of about 1 Newton. If you hold 5 apples, of course, it's about 5 Newton, because 1 apple is 1 Newton, so 5 apples about 5 Newtons. Next, students, measuring pushing force. If you stand on the weighing scale, you press down on the scale, and then the reading on the dial increasing. You can use scale like this to measure pushing force, students. You need a set of the scale with measures in newtons. If it gives a reading in kilogram, you need to know that 1 kilogram means 10 newtons. 2 kilogram means 20 Newton, and so on. How about 5 kilograms, students? How much the force, students? Yes, 50 newtons. Look at the picture. There is three ways of using weighing scale to measure force, students. First, you can stand on the scale to measure the downward force of your weight. The second one, you can use your hand to press the scale against the wall. This measures the pushing force of your arms. You can use your feet instead. This measures the pushing force of your leg. Based on this one, students, we can make a summary. 1. Forces are measured in newtons or capital N. Forces are measured using force meter. If you still confused, students, you can write down the question in Google Class. Okay, remember, if you any doubt about the chapter, you can type the doubt things in the Google Class, and then directly I will answer it to you. Next, students, subchapter 9.3. Weight, the pull of gravity. We know that we live on the earth, right? It is difficult to get away from the earth. If you jump upward, you will fall back down again. The earth gravity pull you downward. The earth gravity causes a force that pull any object downward. This force is called weight. Like any other force, weight is measuring in newtons or capital N. Gravity always pull you toward the center of the earth. It doesn't matter where you are on the surface of the earth. When we draw the force arrow to represent the object weight, the arrow points toward to the center of the earth. For example, like this. There is 5 people in the surface of the earth. As the definition, students, the gravity always pulls person toward to the center of the earth. Of course, for this picture, for this man or this person, the gravity force will be going to the center, going down. This one is going to the center, diagonal like this. And this one is going diagonal up, like this. Remember, gravity always pulls person or object toward to the center of the earth. Another concept, students, falling through the floor. The earth gravity is pulling on us all the time. It pulls downward, right? But we don't fall through the floor. Why not? The floor pushes upward on us with the force, students. This force is called contact force. Any objects that contact with the floor, of course, there is upward force caused by floor. So that's why we can call that one is contact force. Any object that you push on pushes back with contact forces. Usually, the force is big enough to balance the pull of the gravity. But if you stand on something that is not very strong, its upward push may not be enough to support you. For example, if you stand on the chair, but the chair is weak, so that's why you can fall down. Why? Because the force of the gravity is big enough to make the chair breaks. As long as the contact force equal with the gravity force, of course, you can stand up properly. Next, students, mass and weight. What the difference between mass and weight? Students, when you weigh yourself at home, the scale shows the value in kilograms. You might say I weigh 50 kilograms. However, in science, we will say that your mass is 50 kilograms. The mass of the object is measured in kilograms. It tells you the amount of matter the object is made of. One more time, what is mass? Mass is amount of matter the object is made of. Doesn't matter where you are, the mass is the same thing, students. Let's see, in the earth, your mass is 50 kilograms, and then you move to the moon, your mass will be the same thing, that is 50 kilograms. The earth of gravity pulls on its kilogram with a force about 10 newtons. So, if your mass is 50 kilogram, your weight on earth is about 500 newtons. Means that you have to multiply by 10 to find the weight. For example, if your brother has 80 kilograms of the mass, of course, the weight will be 800 newtons. Imagine, students, if you are going to the moon and then the moon gravity is weaker than the earth, your weight a lot less up there. Why? Because the gravity is weaker. You can jump much higher on the moon, but you still fall back downward because the moon have gravity. If you go far out into space, far from the earth, moon or any other planet, your weight is zero. Your mass stay the same. However, you are still made of 550 kilograms of matter. From this subchapter, we can make conclusions. Mass is amount of the matter in object measured in kilograms. Weight is the force of the gravity and object. Remember, students, mass doesn't change wherever you are, including when you want to go to the space or you want to go to the moon or other planet, your mass still the same thing. But weight is depend on the gravity. If the gravity of the planet bigger than Earth, means that your weight will be bigger. Okay, students, if you have any doubt about the concept, please let me know. Write down the question in the Google class, and then I will give you more information about the chapter. Okay, students. Okay, next, students. Because the explanation is done, so that's why I will give you classwork. You have to do this one, find the answer, and then directly send the answer through email that teacher already gave to you. Okay, the usual email if you want to submit something. Okay, this one is classwork number 1 until number 4. Doing in binder paper or another paper is fine, as long as you can send the answer to me. Okay, another one, after you do this one, students, you can continue with the activity. This one is the activity, the simple one. Okay, students, measuring force with the rubber band. Okay, what will you do, students, for the activity? First, you are going to investigate force in several objects in your house. Okay, use rubber band. So that's why you have to find the rubber band. After you find the rubber band, cut your thicker rubber band to be straight rubber band, and then measure the length of the rubber band. Okay, after you measure the length of the rubber band, give the name as L0. That one is initial length. Okay, then number 4, find object in your house that has different mass, students. You can choose every single object in your house. Okay, remember, you don't need to measure the mass, just find the objects. Okay, then number 5, tie the object up with the rubber band, then hang it. Measure the changing of the rubber band length with the ruler, students. Okay, remember, you already calculate the initial length, and then after that hang the object in the rubber band, right? So there is changing of the length, and then record the length. Okay, after there is object in the rubber band. Next, repeat number 5 for other objects. Remember, you already find 5 objects, right? So that's why you have to do the same thing with other objects, and then record the result in the table below. This one is the result, students. You have to make the table like this, and then for example, I use my books. Okay, I tied my book with the rubber band, and then calculate the length before and after, and then after that I find the gap. Okay, the final minus with the initial length. Okay, how about the force? The force is you can calculate like this, students. 1 centimeter of the length is represented by 10. If you, let's see, in this table, okay, you already get 2 centimeter. So 2 centimeter times 10. So this one is 20. Or after you find the gap between the initial and then the final, let's see, the result is 5.2 centimeter. So 5.2 centimeter times 10. The result will be 52 newtons.